Hi everyone, this is Dhanasekaran, Assistant Professor, Department of Electronics and Communication Engineering, K.S. Rangasamy College of Technology. Today I'm going to discuss about junction photodiodes in the module name of optical detection devices in the optoelectronic devices course. So this is the overview of our topic. First one is introduction to the junction photodiodes, principle of photo detection, types of junction photodiodes, structure and composition of junction photodiodes, dark current and noise statistics, applications of junction photodiodes, advantages and limitations, future trends and developments. These are the overview of our topic. And before we going to start the junction photodiodes, we should know about the basics of junction photodiodes. The junction photodiodes are the semiconductor devices designed to convert a light into electrical signals. So basically, here we going to convert one form of energy into another form of energy through the junction photodiodes. So here the light energy converted into electrical energy. They are crucial components in the optical detection system, enabling the conversion of photons into a measurable electric currents. So this process relies on the photoelectric effect, where the photon with the sufficient energy interact with the semiconductor material, generating electron hole pairs. So generally it's generating electron hole pair. Then these pairs contribute the flow of electrical current, so that it providing means to detect the quantify the incident light. So junction photodiodes are distinguished by their unique structure comprising PN junction region of where the P-type semiconductor material and the N-type meet. So junction forms a depletion region, the region devoid of free charge carriers with the built-in electric field. The junction they are commonly used in the application requiring sensitive light detection, including optical communication, medical imaging, and environmental monitoring. These are the principle of photo detection. The first one, the photo absorption, electron hole for generation, charge separation and collection, and photocurrent generation. So in this photo absorption, the energy band gap, that is the greater energy than the band gap of the semiconductor material are absorbed in the depletion region. In the electron hole pair generation, each absorbed photon generates an electron hole pair to contribute the photocurrent. So as I said earlier, the electrical energy is produced whenever the light incident in the photons. Sorry, the built-in electrical field at the PN junction separate the electron hole pairs in the charge separation and collection. Whereas in the photo current generation, the flow of these separated charge carriers consists of photo current, which is proportional to the insulate intensity. Whenever the light intensity is will high, the photo current will proportionally it's going to be a high. These are the types of photodiodes. The first one is PN junction diode, pin photodiodes, and heterojunction photodiodes. So the similar difference between these three types. So first one is we have PN junction photodiodes. P-type and N-type semiconductors are used in the pin photodiodes. We intrinsic layer we used in the P-type and N-sem to enhancing the electric field and increasing the volume of the photo absorption. So we have to increase the photo absorption volume in terms of getting the quantum efficiency and the response speed. So coming to the heterojunction photodiode, these utilize the different semiconductor material for P and N region. So allowing for tailored properties like improving efficiency or response characteristics like. So these are the structures and composition of PN junction photodiodes. One is the PN junction, depletion region, contact layer, and semiconductor material. As we discussed in the first slide, the PN junction is the form of the heart of photodiode, and the depletion is whenever the The region divided for the free charge carriers, it's essential for the charge separation and photocurrent generation. So contact layer typically metallic, and it obviously provides an electrical connection to the devices, allowing the external circuit interaction. In the semiconductor material, the photodiodes, it's carefully chosen for its bandgap energy. Whenever it's reduced, the current flow will be high, and which determines the spectral response of the devices. This the graph shown that the photodiode, that is the current graph, that is sensitivity and responsivity, the measure of diode ability to detect the small changes in the light intensity. And responsivity is the ratio of photo current generated to incident light power, quantifying the device efficiency in converting the light into a electric signal. And the next one is the spectral response and quantum efficiency. It's very important to measure the spectral responses and the quantum efficiency. The spectral responses describe the diode sensitivity to the different wavelength of light. So we'll receive the different wavelength. We have to convert into that light into an electrical energy. So it's a typically characterized by the peak responsivity at the specific wavelength. Coming to the quantum efficiency, the ratio of electron and hole pair generated in the initial light photons, indicating the diode efficiency. So it's converting photon into a charge carrier. So the light energy, that is a photon energy, it's converted into the charge carrier. And coming to the dot current and the noise characteristics, here the increased availability, reduced immunorejection, and faster recovery and improved vision. This will helps the characteristics to improve. We have to generate the more charge carrier whenever we consider these points. And coming to the application of junction photodiodes, we have the optical fiber communication and medical imaging and industrial sensing. So in optical fiber communication, we detecting the light signal transmitter over the fiber optic cable. It's the used in the mobile communication or medical. Different the various applications are coming under the optical fiber communication. And whereas in the medical imaging, used in the medical imaging technique such as CT scan and optical coherence demography. And the industrial sensing, monitoring lights levels in the industrial process and the environment, which is based on the speed and its accuracy. And these are the advantages and limitations of the junction photodiodes: high sensitivity and fast response time, and wider spectral responses. And the coming to the limitations, it has some limitations. The operating temperature can affect the diode performance. Whenever the temperature increases, the diode performance will be less, or the potentially leading to increased dark current and noise. That whenever it increased, so we didn't get any the lot amount of charge carriers. The susceptibility to radiation damage. So exposure to high level of radiation can degrade the diode's performance. So we have to reduce the radiation, and the starting its lifespan is very short. That is the limitation of junction photodiode. And the coming to discuss about the future and trends and developments in the junction photodiode. So we have the enhanced sensitivity, wider spectral range, and integration with the other technologies. That the photodiode are being integrated with other technologies, that is microelectronics, photonics, creating more sophisticated optical sensing devices. Discussing about the viral spectral range, the semiconductor material fabrication technique being explored to spectral response range of photodiodes. So thank you so much for watching video. Thank you all.